Hello everyone and welcome back to the AWS Solution Architect Associate series. Today we continue domain 3, that is design high performance architectures, and our focus is on critical topic which is determining high performing and scalable network architectures. In this video we will explore AWS Edge networking services, subnet tiering, routing strategies, load balancing, hybrid connectivity, and also how to design the network architectures that scale globally and meet performance, latency, and availability requirements. This task tests both conceptual understanding and real-world architecture designing skills and is very common in the SAA C03 exam. Let's get started. When designing a high-performing network architectures, edge networking plays a major role. Amazon CloudFront caches the content at AWS edge locations, dramatically reducing the latency and offloading your origin servers. It's ideal for static content, APIs, media, and websites. AWS Global Accelerator uses the AWS Global Backbone Network to route user traffic to the nearest healthy endpoint, improving the performance for globally distributed users. It offers static IPs, intelligent routing, and fast failover compared to the DNS-based solutions. By combining CloudFront for content delivery and Global Accelerator for optimized traffic routing, you can significantly improve the network speed, reliability, and user experience across regions. High-performing architectures begin with strong VPC design. A typical architecture separates the public subnets for load balancer and net gateways and private subnets for application tiers and databases. Route tables determine how traffic flows. Public subnets is for internet gateway connects with internet gateway, private subnets connects with the net gateway, isolated subnets connects with no internet access. IP planning is equally important, that is selecting the CIDR ranges with enough IP addresses ensures that the architecture can scale as the traffic grows. Proper network segmentation improves the performance, reduces the latency bottlenecks, and enhances security. Load balancer distribute the traffic efficiently across multiple compute nodes. Application load balancer operate at layer 7 and provides features like path-based routing, host-based routing, and WebSocket support, making them ideal for modern applications and APIs. Network load balancer offers ultra low latency with the ability to handle millions of connections per second, which is perfect for streaming or the gaming workloads. Gateway load balancer integrate third-party firewalls and the inspection systems at scale. Enabling the cross-zone load balancing ensures that the traffic is evenly distributed across all availability zones, improving the resilience and performance. AWS provides several connectivity options for hybrid and multi-VPC architecture. Site-to-site VPN offers the encrypted connectivity over the internet suitable for quick and cost-effective hybrid setups. AWS Direct Connect provides a private dedicated connection to AWS with low latency and high throughput. It is ideal for enterprises transferring the large volumes of data. AWS Private Link offers the secure private connectivity to AWS services without exposing traffic to the public internet. For multi-VPC communication, VPC peering works for point-to-point links where Transit Gateway enables the scalable hub and spoke architectures with centralized routing. Choosing the right connectivity option ensures scalability, performance, and security. When building the network topologies for performance, the goal is to reduce the latency and optimize the traffic flow. A multi-tier topology separates the presentation, application, and data layers for better manageability and scalability. Hybrid architectures integrate on-premise networks with AWS using VPN or the Direct Connect, ensuring the seamless and secure communication. For enterprises, centralized egress via security VPC simplifies traffic inspection and enforces compliance. A well-designed topology ensures the workloads can grow and evolve without requiring major re-architecting. When designing networks at scale, it's important to think ahead. AWS load balancers automatically scale with incoming traffic, removing the operational overhead. Multi-AZ deployment ensures that the architecture remains resilient even if one zone experiences issues. Capacity planning for NAT gateways, IP ranges, and VPC subnets avoids the running out of resources as the traffic grows. By designing with elasticity in mind, the network can seamlessly handle the traffic spikes and future growth. Placing resources in the right location dramatically impacts the performance and cost. Placing compute resources close to the users and using CloudFront reduces the latency. Databases and compute may be placed in the same availability zone to minimize the cross-AZ transfer latency while still using the multi-AZ for high availability. Architect must balance the latency, throughput, and cost when deciding where workload should run. Selecting the right load balancing strategy is the key to high performing architecture. Use ALB for HTTP and HTTPS microservices and serverless backends. Use NLB when you need extreme performance, static IPs, or the TCP UDP support. Use Gateway Load Balancer for large scale firewall deployments. For global users, you may combine load balancers with Route 53 latency routing or the Global Accelerator to achieve global high performance and availability. Many architectures require multiple VPCs or the hybrid connectivity. Transit Gateway is the best way to scale because it centralizes the routing and supports thousands of VPCs and on-prem networks. Enterprises commonly use a shared services VPC for DNS, authentication, monitoring, and security tools. This reduces the duplication while improving the consistency and performance. High-performing network architectures combine the multiple AWS services to deliver the low latency, high throughput, and global scalability. Edge networking improves the speed, scalable load balancer distribute the traffic efficiently, subnet tiering enhances the security and performance, and hybrid connectivity integrates the on-prem workload smoothly. Designing a scalable architecture means understanding AWS building blocks and combine them effectively for your workload needs. So to summarize, in this session we explored how to design the high-performing and scalable network architectures using AWS services. We covered edge networking, subnet architecture, routing strategies, load balancing, hybrid connectivity, and how to place the resources for optimal performance. All these concepts are critical not only for the exam but also for the real world architecture. In the next video, we move forward to determine high-performing data ingestion and transformation solutions, where we will explore Kinesis, Glue, data sync, lake formation, Athena, and much more. If you are enjoying this series, don't forget to like, subscribe, and share. See you in the next session. Thank you.